Hi, I'm Herb Gross, and welcome once again to our video series, Mathematics as a Second Language, where today we're going to introduce the concept of percents, which again seems to cause students much more trouble than they should. And I believe a lot of it, again, has to do with memorizing things as opposed to understanding them. As I'll illustrate throughout the lecture, all percent means is percent is per hundred. And in terms of the cornbread model, all it means is that you are dealing with a cornbread that has been pre-sliced into 100 pieces. So each piece is what? 1 of the 100, 1% of the whole cornbread. So if you're comfortable with the idea of dividing the cornbread into pieces, obviously you don't want to do this physically because it would take the whole term to divide the cornbread into 100 equal pieces explicitly, but at least we can talk about it. You might want to introduce this by talking about per 10 instead of per 100 and actually drawing these things so the youngster can see it. But let's just take a look at something. Let's suppose you're taking a quiz, and on the quiz there are 5 problems. And you've never heard of fractions per se, never heard of percents, you haven't heard of anything. Haven't you ever gotten back test papers where if there are 5 problems, the instructor might say, let's say you got 4 right, 1 wrong. The test comes back 4/5, which you read as 5 was a perfect score, and you got 4 right. You don't even have to identify this with 4/5. It'll happen naturally later on. But what it means is, whatever the perfect score was, if you divide it into 5 equal parts, you scored 4 of those parts. See, in other words, let's suppose you've always been having trouble with math, and one day you take a test with 5 problems, and you get 4 right, and the instructor writes 4/5. You come home, and you're all excited, and your mother says, well, you look happy. Did you do well in math today? Oh, did I do well? I got a 4. And your mother doesn't rejoice. Why? She doesn't know that it was 4 out of 5. What are you usually thinking of when you talk about a test score? The perfect score is 100. Okay? So what you really want to say to your mother is not that you got a 4. You should argue in your own mind something like this. Since 5 was a perfect score, and I want to base everything on the basis of 100, let's call the perfect score 100 points. I'll divide the perfect score into 5 equal parts. Each part will be worth 20. I got 4 of those parts right. 20 times 4 is 80. So what I'm saying is 4 does not look like 80, but 4 on a scale of 5 is the same rate as 80 on a scale of 100. And it didn't matter what the perfect score was. Suppose the perfect score was 60. Well, divide the 60 into 5 equal parts, 12, 12, 12, 12, right? 60 divided by 5 is 12. How many of those parts did you get right? So now you have a 48. 48 what? 48 based on a perfect score of being 60. So what you're saying is 4 on a scale of 5 is the same as 80 on the scale of 100, is the same as 48 on the scale of 60. Okay. Now, for whatever the reason is, people always like to pick a perfect score to be a power of 10. You'll hear people say on a scale of 1 to 10. So if somebody, in my generation, they would talk about in dating, the woman was a 10. That meant you couldn't go any better. So you could make a good news, bad news story out of that. Somebody is arranging a blind date for me. I say, how is it? She says, well, it's good news and bad news. I say, tell me the good news first. Well, she's a 10. I says, what's the bad news? Perfect score would have been 1,000. Okay? The 10 doesn't tell me anything until I know what the perfect score is. So what do? We deal per 10, per 100, per 1,000. And the one that we usually focus on for percent is per 100. So when you write 78%, it means 78 on a scale of 100. By the way, the origin of the percent sign, just historically, came from taking this, leaving out the slash mark and putting it between the ones and the zero, so that you wound up with your percent sign eventually evolving into this. It was a corruption of this. So in other words, when you say percent, the scale is always based on 100. And here's why mixed numbers are so important. Up until now, every problem that we did for a perfect score, it was divisible by the number of problems that would have been a perfect score. Suppose there were 7 problems, and you got 6 right, and you now wanted your answer as a percent. 6 on a scale of 7 is exactly what? In other words, 6, we'll call it 6 out of 7, equals question mark out of 100. You follow that okay? Now here's the problem. If you count by 100 is not divisible by 7. If you count the multiples of 7, the 14th multiple of 7 is 98. So 98 is too small to be 100. The next multiple would be 15, but 15 times 7 is 105. That would be too big. But watch what we can do. We say, let's suppose the perfect score was 98. See, why is that? Because 14 times 7 is 98. So each piece would now be worth 14. How many did you get right? 6 of them. 6 times 14 is 84. So on a scale of 98, 6/7 would be worth 84. Okay? 6 on a scale of 7 is 84 on a scale of 98. What would happen if the perfect score was 105? Well, now each of these 7 pieces would be worth 15 points. You again got 6 of these right. 6 times 15 is 90. So what you're saying is, look, if the perfect score had been 98, I would have gotten an 84. If the perfect score was 105, I would have got 90. Since 100 is between 98 and 105, I must have done better than this, but worse than this. In other words, I got more than 84%, but less than 90%. Now, if all you're interested in was your grade, knowing that was more than 84 but less than 90, you know you're in the middle to high B range for the grade. But if you're dealing with a multi-million dollar, a multi-billion dollar corporation, the gap between 84% and 90% can be enormous. You say, I would like the exact answer. It's not enough to know it's more than 84% but less than 90%. Well, the way you could do that is you say, well, what are we looking for? We've opted to call the perfect score 100%. Okay, that's our choice. And I want to take 6/7 of that. Well, of means times. We saw that when we discussed fractions. So what does this become? 6 times 100 is 600, divided by 7, see, over 7. It's 600 over 7%. That's an improper fraction. We can write that now as a mixed number. In other words, it's 600% divided by 7. And if we divide 600 by 7, it goes in 8 times with a remainder of 4, goes in 5 times with a remainder of 5. And so the exact answer is 85 5/7%. In other words, if you want to be exact, if you own 6/7 of a corporation, say, and you wanted to do that as a percent, based on 100%, you own 85 5/7% of that corporation. By the way, notice something interesting. Up until now, we said to take a fractional part of a number, you divide by the denominator and multiply by the numerator. And that was because the denominator was always a divisor of the unit. Look what we did over here. When we said 6 times 100, we were multiplying by the 6 first, and then we divided by the 7. In other words, it doesn't make any difference whether first you divide by the denominator and then multiply by the numerator, or whether you first multiply by the numerator and then divide by the denominator. The usual rule of thumb is if the unit, if the perfect score is a multiple of the number of questions, divide first because it makes the number smaller. If it isn't, multiply first so that the mixed number comes up as your last step rather than as an intermediary step. Okay? Once you understand what we did here, you don't have to memorize anymore. Let me give you an example. When I went to school, we studied things, I think they were called aliquot pots. I forget exactly what the word was. But we memorized that a half was 50%, a fourth was 25%, a third was 33 and a third percent, and a few others, like an eighth, a twelfth. But we never memorized what say 5/13 was. I want you to see that no matter what fraction I give you, you can convert that into a percent, because the whole amount would be 100%. So when you say 5/13, you're taking 5/13 of 100%. All you have to do is multiply the 100 times the 5, the 1 times the 13. You get 500 over 13%. You carry out the long division, and the answer comes out to be what? 38 with a remainder of 6. 6 is what? 6 out of a possible 13. So the exact answer is 38 and 6 13. Do I have to memorize that? No, because every time somebody gives me a problem like that, I will just work the problem out if I don't remember what it is. And again, the cornbread model is a tremendous help in this case. See, the cornbread comes pre-sliced into 100 pieces when you're dealing with percents. In other words, 1% of the cornbread is 1 piece. Now, to take 5/13 of the cornbread, that's 5/13 of the 100 pieces. There's the same 500 over 13 that you got before, but the noun is now nouns, okay? So it comes out to be what? 38 whole pieces with a remainder of 6 as we got before. So it's 38 pieces plus 6 13 of another piece. So the answer is 38 and 16/13%. See, we see that in terms of the cornbread. Notice how the word piece takes away the whole worry about percents, okay? Now, you might not even like the idea of having to write 6/13 of a piece. You can avoid having to deal with 6/13 of a piece. Simply divide each piece into 13 smaller pieces. See, we did this before when we wanted to take a half of a third. Do you remember? We started with thirds. And to take a half, we just divided it into 2 regions this way. So a half of a third came out to be this. Now, you wouldn't want to draw this in this case, but what's happened is what? The cornbread has already been pre-sliced into 100 pieces like this. So if I now make 13 horizontal cuts, each of the original pieces is now cut into 13 smaller pieces. So in other words, assuming that the cornbread has 100 vertical pieces, we can make 13 equally sized horizontal pieces, and there will now be 13 times 100 smaller pieces. You see 100 times 13. 100 this way, 13 this way, there's 1,300 pieces. So now watch what you can say. The cornbread is 100 regular pieces, and it's 1,300 smaller pieces. I put the word regular in quotation marks here simply to indicate that that's the way it came pre-sliced into 100 pieces. And we know that by how we divided it up, that 13 smaller pieces is 1 regular piece. Now watch what happens. Now when we take 5/13 of the cornbread, by using smaller pieces, we're taking 1,300 smaller pieces. And the beauty of this is we constructed this so we now know that the total number of pieces will be divisible by the denominator. 13 goes into 1,300 100 times. 100 times 5 is 500 smaller pieces. And remember that each of the smaller pieces, you needed 13 of them to make a whole piece. So there's your 513% again. But notice the psychological difference of saying the 500 is modifying smaller pieces as opposed to 1/13 of a percent. So to summarize again, just to make sure we see it, See, 5/13 of the cornbread is 500 of the smaller pieces. One regular piece, which is 1% of the cornbread, and it takes 13 smaller pieces to make one regular piece. So to convert the 500 smaller pieces into regular pieces, since there were 13 smaller pieces per regular piece, you divide the 500 by the 13. There's the same 38 and 6/13 again, and there's your percent. So again, you see how the adjective noun theme works in a case like this. It's just simply a matter of replacing fractions that may be intimidating to a student by pieces which won't be intimidating. And after a while, without even you emphasizing it, the students will evolve into seeing fractional parts and pieces as being pretty much the same, and they'll be doing these things almost without thinking about it. It still may be by memory, but they'll understand where the rote came from. And by the way, you can reverse the process also. Suppose you started with the percent, and now you wanted to know what fractional part that was. Suppose you have 6 3/11%. Well, that's 6 3/11 per 100. And if you don't like mixed numbers, notice that by multiplying by 11, the mixed number would disappear. See, 11 times 6 is 66. 11 times 3/11 is 3. 66 plus 3 is 69. So multiplying by 11 here would give you 69. But now you have to multiply by 11 here to keep the rate the same. 11 times 100 is 1100. So in other words, 6 3/11 per 100 is the same rate as 69 per 1100. And that's 69 1100ths. And if you wanted to do this mechanically, which is the way I was taught, I was said, look, pretend the percent sign isn't here. You would have got, what, 69 over 11. And percent means per 100. That means to divide by 100, so just tack on 2 zeros. I could have said that mechanically, but notice if I say that after I've done this, it becomes much easier to see why this worked. What gave you the right to just tack on the 2 zeros in the denominator? Again, what I want you to see from this is that percents do not have to be scary, because we can always convert to pieces of the cornbread, but almost more importantly, that the price that you pay for using percents is that you very often are going to have to deal with mixed numbers, because 100 has very few whole number divisors. That's the problem with using percent. You go, if the number of pieces is not a divisor of 100, the answer to a percent problem is always going to be a mixed number. And I think that's enough for today's lesson. Let's end our course for today by just doing another practice problem. Look at the problem, pause the video, and then come back after you've solved the problem. And the practice problem today is, if you own 48 2/3 of the stock in a small company, what fractional part of the shares do you own? I think this would be worded better if I replace stock by shares. So there's no danger of confusing what the unit is. So you own 48 2/3% of the shares, and you want to know what fractional part you own. Okay? That's your task. Now, to solve the problem that we just gave, again, let's go back to our reality check. 48 2/3 is a little bit less than 50%, right? So 48 2/3 is a little bit less than 50. So 48 2/3% is a little less than 50%. 50% is half. So the answer should be a little less than half, a little bit less than 50%. So let's see how we do this. If we were doing this the mechanical way, we would say 3 times 48 is 144, plus 2 is 146, over 3, tack on the 2 zeros. The logical way is 48 2/3% means 48 2/3 per 100. So if I take 100 3 times, I'll be taking 48 2/3 3 times. That tells me what then? I have 3 times 48 2/3. That's where I get my 146 from. I have 3 times 100. That's where I get my 300 from. So the answer is what? Per means divided by. Answer is 146 over 800, which reduces to, divide numerator and denominator by 2, reduces to 73 over 150. Notice that 75 over 150 would have been a half, so taking 73 out of 150 is taking a little bit less than a half, and that's exactly what we said was going to happen. And I guess that brings us to the close of today's lesson. I'm looking forward again to seeing you next time that we meet. And until then, stay young, have fun, work hard.